In today's installment of Affinity Energy's I&C Short Tips, I'm going to talk about some best practices around data acquisition and SCADA systems, with the general theme that just because you can doesn't mean you should. In today's world, many of the devices and equipment that we have to integrate are very smart, and they contain a wealth of information. And one of the challenges that we see and tends to drive up the cost in implementing SCADA systems is either over-specification of what needs to be integrated in terms of the types of and quantity of points, as well as the frequency or the density with which you acquire those points, or the opposite, which would be not enough specification. What we typically find in a lot of our systems, for example in mission-critical data centers, is we have smart devices. We could have a meter that can provide several hundred points just from a single metered point in an electrical distribution system. And typically what we find with engineers who are doing the specification work is there's not enough time in the planning process to specify what of the 100 points is required in order to satisfy the particular needs. You know, if the customer is doing perhaps energy reporting or cost allocation, or if they're looking at power quality, or maybe they're just trying to, for a data center, calculate PUE, the specifics of what are required to accomplish that goal are significantly different. Most SCADA systems are priced based on a point quota, so the number of points that are in the overall system, but also the amount of work and effort in order to do the integration is directly related to the number of points. The other aspect is, as these systems scale up and they become larger, so I talked about several hundred points per meter, well, it might not be uncommon to have 100 meters in a big data center. So as you can imagine, the number of points increases substantially. And that pays a price in terms of performance. A lot of systems, if you have several thousand points or hundreds of thousands of points, that becomes quite a task to collect those points, to alarm on them potentially, or to historize them. So again, a word of caution that we have and that we try to take in our designs and during our design process is to work closely with owners to really understand their end goals and objectives, and to tailor that point list for that device to support what those goals are. And anything that's extraneous to those goals we try to leave out. Oftentimes we have the extreme where the engineer just gives us the type of device but gives no guidance on the number of points. If we have the opportunity to meet with the owner, we certainly are going to try to understand what points need to be acquired, alarmed, and historized. In some construction projects, availability of owner or visibility to the owner is somewhat limited. So in a situation where the engineer does not specify the points, most of the time we're going to err on the side of caution, and we might include more points that are required. Again, that leads to greater expense in terms of design, also greater expense in terms of licensing. Smart devices have the ability to communicate at extremely high data acquisition rates. So what that means is the frequency of polling the device. So for example, you might, in a typical maybe building automation or non-mission critical system, you might collect the data every 15 minutes because things like temperatures or humidities or flow rates just don't change that quickly. But in an electrical distribution system, you know, things can change within minutes or even seconds. So again, understanding your application and understanding, you know, how quickly you need to acquire the points is really important, because the size of the database, the size of the hard drive, the amount of activity on the network is all going to be related to not only the volume of the points, but how quickly you want to acquire or pull that piece of equipment. One strategy that I recommend when you do need to have a high rate of data acquisition is, instead of setting the device up to acquire the data at that rate all the time, do it based on a condition. Perhaps it might be an event that occurs in the system. So for example, if you have a sag or a swell, or maybe something like a motor starting, you might set your data acquisition to pull the equipment at a faster rate for a period of time after you start the motor, because you want to see the inrush current, or you want to see something about what's happening when that motor starts, or potentially when power quality starts to stray outside of normal boundaries. But then during normal operations, back that rate off. What I find is that capability goes underutilized in a lot of the SCADA systems. Again, this is just a few of the short tips with respect to maybe optimizing the design and the scale of your SCADA project.